Hello, I'm Stefanos. Welcome to my presentation of the program Modeling and Dynamic Simulation of the Sequence Batch Reactor for Domestic Wastewater. This program has been based on the ASM3+Bio-P model. In this video, I'm going to show you the basics of this application. This model consists of 23 process rate equations and 17 state variables. The computations are performed with the numerical analysis method Rajakata fourth order. The model has been used as it is without simplifications, and the program is very accurate and reliable. It is written with the Visual Basic programming language of Microsoft Excel. As the application is loaded, the first sheet, the Start sheet, appears. Pressing Start, we see the main menu. We can view the current case, the name of the case is this one, or start a new or modify a case. With the Exit Simulator button, we exit the program and we go back to the Start sheet where we can perform the save as commands, close the program and start the program. Let's start a new or modify a case. This is the main input data form. We have two sections, a big one for the input data and a small one for the control buttons. We have two other sections in the input data, the wastewater characterization and the process parameter. What we have here? We have a reactor, sequence batch reactor with this volume that works at this temperature and has to treat this wastewater flow per day at this sludge H, and the sludge has this sludge volume index. We select the duration of the cycle phases, and also we select the oxygen concentration of the aerated phases. We have the wastewater characterization, and we have to put in the white boxes the data, while in the pink boxes we see the results for information. The most difficult part of the input data section is this section where we have to put the fraction, this organic fractions of the COD. These fractions are not difficult, since in the wastewater, domestic wastewater, the values are 0. To find this value, the SI, the SS, XI, XS, XH values, we can use the wastewater characterization help. It is a sheet where we can find these fractions. In this part, we have to input the inorganic components. Let's go to the wastewater characterization help. This is a sheet where we can estimate the various fractions if we have a correct wastewater analysis with data, consistent data. If we put these values, COD, BOD, total suspended solids, total nitrogen, ammonia nitrogen, total phosphorus, orthophosphate phosphorus, and the inorganic particulates, if we press this data and are consistent, then we press this button, calculate fractions. the fractions are calculated, and pressing this button we transfer these fractions to the main input data form. For example, change the total suspended solids. We have a suggestion for the inorganic particulates, 51. Now, if we know the SI fraction, which is found from the COD of the treated water, let's say it is 004, then pressing this button we get the other fractions. Let's go back. The program calculates the sum of the percentages. If the sum is not 100, then the calculation cannot start. After inputting this data, we have to input the inorganic part, which is the XPP. The program up to here calculates the suspended solids due to the above particulates. This is the number. We input the inorganic particulate material, and the program calculates the total suspended solids. Then the ammonia nitrogen, the nitrogen, the nitrate plus nitrite nitrogen, the inorganic soluble phosphorus, alkalinity, and oxygen. Let's go to the cycle phases. There are the fill phase, which is also react phase, anoxic 1 plus anaerobic 1, aerobic 1, anoxic 2, aerobic 2, settle, which is also reactor phase, draw, wastage phase, and idle phase. All phases are treated as react phases. We put here in the white boxes the duration in hours, and here in the aerated phases we put the oxygen concentration. Usually we use two phases, anoxic 1 and aerobic 1. Anoxic 2 and aerobic 2 are optional, but the others are compulsory. As we input this data, we have here this information, which is very useful. Now we have to select the time step of the computations in minutes. The program suggests to use these numbers as the time step. This leads to accurate computations and repeatable calculations. If we place this, we also put here another value, let's say 2 minutes, 3 minutes. The program will work also, but the results are not reliable. As we put here as you see, we put the mouse over this, appears this, we put this, select this number, transfer the time step to the database. And then we will have to select the number of cycles that the program will perform. Usually we put a big number, and the calculations will stop converging in a lower number of cycles. Now the control buttons. We have seen the wastewater characterization help. We have the start button for fast invisible calculations that are very rapid. The start of slow visible computations. The button to view and change the kinetic and stoichiometric parameters, and a button to set or repair the initial value of the calculations. Let's start the fast and invisible computations. We have here, if we press this escape button in the keyboard, the calculation will stop. Now we are in the first cycle. We see here the current cycle number running. At the end of the cycle number, we have this progress of computations, the convergence value, the convergence progress, and the runtime. Convergence value is the difference of the XTSS in two consequent cycles as a percentage of the value of TXS. The program has converged and leads to the results menu. The computations are not so fast. This case has been already converged, so repeating the calculations, the convergence comes very fast. Let's say we have the following buttons. The charts at a glance. We see here 8 charts with the components as and see the values as time variation. If we see, let's say, this for the heterotrophs, we see this straight line which is up to the settling. This increase is due to the settling. It is the heterotrophs in the settling phase. This small part is the wasted phase, and this one is for the rapid mix phase. If we return to the results menu, we can see these charts in detail. With the phosphorus change, the nitrogen change, and the nitrates change. These values, these vertical lines, indicate the end of the phases. Let's see the next chart. Or we can see the previous chart and return. In this sheet we see also above here the convergence value, which must be below 0.004, and here is a table. We can see the cycle clock. Let's go down to the input data and results. In this sheet we see the input data, the wastewater characterization, the process parameters, the cycle phases, the time increments, step, minutes, and here are the results: the effluent quality, the effluent, the output of phosphorus, soluble, insoluble, total phosphorus, phosphorus content of the XTSS. And here the results of the anoxic and anaerobic periods. The anoxic part of fill is this one. There is no anaerobic part during fill, but in the anoxic 1 phase we have anoxic part, which is this one, and anaerobic part, which is this one. This is calculated by the program. And now we come to some parameters which are familiar: the F2M, ratio, the VSS to SS, the water flow at fill, wastage flow, and solids in wastage. Feed volume, idle volume, this ratio, draw volume, wastage volume, and the MLSS in aerobic 1 phase. Also, there is an estimate of the soluble effluent COD and the estimated BOD. Also, it is calculated the aeration required as oxygen, grams of oxygen per cubic meter of influent during the process cycle. Then we can go up. If you see, we can go down to the parameters of at the end of the phases. In this table, we have the following. We have the influent data, the influent components. We have the fill phase, the anoxic 1, aerobic 1, anoxic 2, aerobic 2, settle phase, draw phase, sludge phase, idle phase. And here are the value of the parameters at the end of these phases. It is very useful to see what is going on during settling and what is going on from phase to phase. This is the effluent quality, and this is some other, the feed volume of the reactor, the idle phase volume, and the final sludge volume. Also, this is the convergence value to evaluate how reliable are these values. And this is because during calculations of the fast mode, you may decide that this target convergence value is too small and you would like to stop the calculations. Calculations, as I have said, may be stopped pressing the escape value. You will see it later. Let's return to the menu, and now we can see the overall COD balance. We have the COD in, the COD out from in effluent, in wastage. We have the oxygen which comes with aeration, and the oxygen out in the effluent and the wastage. And there is a comparison which have an absolute error, this error. This error occurs when the time step increment is this one and convergence value is this one. If you change this to higher values, the errors are higher, or convergence values are selected higher, then the absolute error is higher. Let's return to results menu, see the overall nitrogen balance in the same concept. Nitrogen in, nitrogen out in the effluent, in the wastage, and a comparison. And also phosphorus balance at the same concept. Okay, let's return and see the view and change the kinetic and stoichiometric parameters. This is a sheet where we have parameters for the ASM3 model, the stoichiometric parameters for the ASM3 model, and parameters for the Bio-P model. All values which are colored as blue, you may be changed by the user, by you. If we make these changes, you press Save Parameters and return to case menu. Now let's run a what if case. We go back to the input data form, and I would like you to to show you the interruption of fast invisible calculation. Let's say back this 7 and press this one. Calculations are performed, and if we like to stop, we press, now where I press the escape button. I press the escape button, calculations have been cancelled, press OK to see the results. So if we decide to stop the calculation before the target converges value appears, we press escape and we have this the same results, but we have here the convergence value that tells you that these values are not consistent, are not the final ones. It's just for information, just at your will. Now, let's return to the input data form and see the slow visible run of computations. This run is when you have converged with fast invisible computations, and you'll see what you see. Start slow visible calculations. We have also this table. We see here in the fill phase, every step of calculations appear the numbers as changing and the interaction with between them. Also here we have the time of run, current time, cycle number, cycle step, time step, and the phase is anoxic. Now is an anoxic phase. You see here what is going on in the reactions. Unfortunately, we have a very extremely fast processor and computer. These values are very rapid to our eyes. So it says here that we now calculating, we have entered the anaerobic phase. But here it is very useful to see what is going on during settling and what is going on in the draw phase and the idle wastage and the idle phase. This is good for the operators to see the influence of the idle phase in the whole process. If we would like to stop the calculations, we press also escape button, which leads us to this to the same sheet. So if we would like to repeat the calculations, press this button and we repeat the calculation from the point we have stopped. Okay, pressing escape again, we stop, we come back to the input data form, and now we would like to tell you that using this program you can optimize the process, understand the process better. You may size the whole process, the reactor volume, the phases, the duration, and also if you do for the same set of input data, you vary the age, the sludge age, you may see interesting results like this one. This charts indicate the variation of various components running the reactor at different sludge age. This is the oxygen requirements as a function of sludge age, what is going on in this area of sludge age, the phosphorus content of the sludge as a function of sludge age, and the other important and interesting parameters. Finally, I would like to thank you for watching, and also this is my email address.